Hello there. Today we are going to be explaining mathematical functions. Functions are like machines. When graphs describe motion and its behavior, they are also represented in two ways, the normal way and the function notation way. Let's start with this function, y equals x. This means that for every possible y value, x is the same. Let's make a table showing this. Let's start with 1. Y is 1. Then x is 1 too, because our rule states that the 2 points must be the same. And the same thing goes for 2 and 3 and so on. And when we connect the points plotted, it becomes a straight line that expands infinitely in one direction. So these are called linear functions. Also, x is known as the input and y is the output. They are also known as the independent and dependent variables, where the dependent variable changes as a response of the change of the independent variable. Now let's make it a bit harder. How do we graph this function? Y equals x squared. These are called quadratic functions. This means that for every possible y value, x is the same, but squared. Let's go back to our table, starting from 1 again. Y is 1 and x is 1 squared, which is just 1. For our second point, y is 2 and x is 4, and so on. When we continue this pattern with all the points on the graph, it makes this shape, which we call a parabola or the quadratic parabola, which looks like a big U. This function has a vertex, which means a changing point. You can see how the function was going down and started going back up again. The point at which the function's direction changes is called a vertex. Now let's move on to this function, y equals x cubed. What do you think it looks like? Well, 1 and 1 cubed, which is 1 again, 2 and 2 cubed, which is 8, and so on. This is called a cubic function. When graphed, it should look something like this. Same as the previous function, this function also has a changing point. But it's not called a vertex, it's called an inflection point. We call it inflection point because the function continues increasing. Unlike the previous function, which was decreasing then at its vertex, it started increasing. Not all cubic functions follow the same behavior with inflection points, but that's for the future. Now, if you're wondering what the rest of the functions look like, you don't have to worry because they follow the same pattern. Y equals x to the 4th power looks like y equals x squared, and y equals x to the 5th power looks like y equals x cubed, and so on. When we have multiple functions together, there is no way to differentiate between them unless we look at the input, which is annoying. That's why we have the function notation, where we can give special names to functions. Let's work with our previous function, y equals x. We can give this function a special letter, like f, so now it looks like this. F of x is equal to x. This means the same thing as y equals x, but with a special character to give it a name. This also means that whatever goes between these parentheses has to be the same in the input. So here, x is between the round brackets, and so is x in the input. Functions can also be named with other letters like g of x or h of x. With this, we can get started on evaluating functions, which basically means changing the output between the round brackets. Let's work with this function. F of x is equal to 2x plus 3x. To evaluate this function when 2 is the output, we'll have to substitute x with 2 in the input, which becomes this. And when simplifying it, becomes 10. Here's another one. F of x is equal to 4x squared. To find f of 3, we'll substitute x with 3, so it becomes 4 multiplied by 3 squared. And when simplified, it becomes 36. Same thing goes for other functions like logarithmic functions, like this one. F of x is equal to the log of x. To find f of 100, we basically substitute x with 100, which comes out to 2. And note that when logs don't have a base, it's always 10. We can also try them with trigonometric functions. Say we have a function f of x equals cosine of x. To get f of 90, we'll have to get the cosine of 90, which is pi over 2. Note that we used radians instead of degrees for this evaluation. Thank you all for watching. I hope I was able to explain functions well. Make sure to like and subscribe for more.